So today we will be discussing another part B experiment of HDL, that is DC motor interfacing. In the figure you can see there are a lot of DC motor here. DC motor, it is called as a brushless motor because here, and one more thing, the experiment is to control the speed of the DC motor. So how to control the speed of the DC motor is one way is through supply. We need to reduce the voltage here, that's it, the supply, only then it will vary the speed here. So how to do that, let us see in the program. So we have taken PSW as one variable, PDCM and then clock. Clock obviously the input and pulse PSW, that is also, and here based on the width of the pulse we are going to vary the speed, so that is vary the voltage, that is the input which we will be providing. Internally we will be controlling the speed of the DC motor. So you can see here the input output I have declared and we have taken it as register, so that the point is we are going to use a behavioral model here. Similarly clock and clock divider is used here also in order to provide less frequency, in order to reduce the frequency. We need to begin this, so we have taken it as process 1 and 2. So first to divide the clock, serial clock division, and then using a counter here, one count which is equal to 8, one tick of bit 0. And we are going to begin this at positive edge of the clock, and if begin at process 1, so count equal to count, initially the count will be equal to count plus 1 for the positive edge of the clock, and then we are assigning clock 1 to the count 7. Always at the positive edge of the clock 1, this clock 1 is nothing but the one provided by the clock divider, and then we are beginning with the this P1 and P2 are just the names given to the processes. If the serial clock divider, which is equal to 12 tick bit, this is in terms of hexadecimal we are writing, so begin, and then we are going to convert it. We are setting the serial clock division to 00. If it is equal to AF0, then we are going to reset the clock division, or else we are going to increment it, so clock divider plus 1, and always at the positive edge of the clock. If this is equal to 0, then we are going to start the DC motor. So and then here you can see this particular serial clock, right, and we have taken 0 0. First thing is, if our PSW will be equal to 0 0 0 and our serial clock also equal to this particular value, which is equal to 30, and this is 40, 50, 60 and so on. Okay, so we have given certain value here, so that we need to, while selecting 0 0, and if it is 30, then we are going to change the speed. Similarly if it is 1, and then, so like that we are going to assign different values here, so that we can change the speed of the DC motor. Okay, I'll go with the program. I have already dumped the program here, and then you can see I have selected our Spartan 3 microcontroller here, and then program. I'm going to dumping the program. The program is succeeded, so I have dumped my program into the kit here. The same kit I'm using, the Spartan 3, and you can see here this is the same particular module is used for the DC motor and the stepper motor. So here I've connected my DC motor here. If I would connect here, it would be my stepper motor. I've connected the JTAG, so even to dump the program. Okay, and let us see how to change here. So using this particular pin numbers, that is the key here, right? So if I would turn it on, I can change the speed of the DC motor here. Just you can take a look at this. You can see here. Okay, you can see here. If I need to reduce, I'll go back. See, now it is even reduced. So this is how, by changing the pulse width, and that means internally the voltage, I'm going to control the speed of this DC motor. Okay, I hope you understood. Thank you.